Hello all, this video is about the applications of EMF calculations. So EMF calculation can be used to determine some other parameters. For example, by using the measured EMF or by using the calculated EMF, we can find out the ionic product, solubility product, and we can find out the degree of dissociation, and we can find out the hydrolysis constant, etc. So this video going to the details of this, that is how can we use the calculated EMF value to find out ionic product, solubility product, hydrolysis constant, or how can we find out the degree of dissociation from EMF value, etc. So let's go to the details. First of all, how can we find out ionic product? By using EMF value. Okay, let's calculate the ionic product by considering a cell like this. Platinum, H2 and KOH, potassium hydroxide, KCl, AgCl, Ag. So these two are electrolytes, KOH and KCl. This is solid. This is also a solid substance. This is a gaseous substance. So we have to mention the pressure. Let's take it 1 atm. Its molarity is M1 and this is M2. The cell reaction is like this. Cell reaction AgCl plus H2 gives AgCl Ag plus Cl minus and plus H2 will be converted into H plus. So here we are going to consider only one hydrogen. So balanced equation will be like this. AgCl plus half H2 gives Ag plus Cl minus plus H plus. So the E value, according to Nernst equation, E equal to E0 minus RT by NF ln concentration of products divided by concentration of reactant. Right. Here we are going to consider the effective concentration, that is activity. So here activity of Ag into activity of Cl minus into activity of H plus divided by activity of AgCl into activity of H2 here half. So this will be raised to 1 by 2. So here this is Ag is a solid substance and the AgCl is also a solid. We know normally the concentration terms of solids are considered as unity. So these two will be 1 and 1. And the activity of H2 also considered as 1. So activity of Ag equal to 1, activity of AgCl equal to 1, and activity of H2 is also equal to 1. So we can write this as E equal to E0 minus RT by NF ln ACl minus into AH plus. Okay, E equal to E0 minus RT by NF ln ACl minus into AH plus. To convert it to a simple equation, I'm going to multiply and divide the term activity of OH minus into this equation. So into E equal to E0 minus RT by NF ln ACl minus into AH plus into AOH minus divided by AOH minus. Since I am multiplying and dividing by using the same term, there is no change, right? And here check, this is AH plus into AOH minus. So if we consider the ionic product of water, that is H2O gives H2H plus plus OH minus. So here ionic product will be like this, Kw equal to concentration of H plus into concentration of OH minus. So, or we can say Kw equal to activity of H plus into activity of OH minus. So this term can be rewrite as Kw. Okay. So this will be equal to E equal to E0 minus RT by NF ln ACl minus into Kw divided by AOH minus. And I'm going to split this term into two, that is E equal to E0 minus RT by NF ln Kw minus RT by NF ln ACl minus divided by AOH minus. And if I bring E0 term into left, then E minus E0 equal to minus RT by NF ln Kw minus RT by NF ln ACl minus divided by AOH minus. So by using this equation, we can plot a graph like this. So here in this equation, E minus E0 equal to RT by F ln Kw minus RT by F ln ACl minus divided by AOH minus. This is same as that of y equal to mxc. This is y, this is m, x and c. Minus sign is there. So x-axis is E minus E0, y-axis is ln ACl minus divided by AOH minus, and we'll get a graph like this. The slope is minus RT by F, and EMF value at the infinite dilution will give the intercept value minus RT divided by F ln Kw. So from this we can easily calculate the ionic product of any substance. Okay. The next one is solubility product. So let us consider a partially miscible substance MX solid. So if we add water into this, that is if we make a solution of MX, we'll get M plus ions and X minus ions. These two are aqueous, and if we prepare a saturated solution of MX, we'll get an equilibrium like this, and the solubility product KSP of MX equal to concentration of M plus into concentration of X minus. And one more thing we have to know about this equilibrium reaction is, at equilibrium we know delta G, change in Gibbs free energy, equal to 0, right? So delta G, we know delta G equal to minus NFE, and since delta G equal to 0, this value is also equal to 0. Here N and F are constant, so that means E equal to 0. Right. So at an equilibrium reaction, E value is also equal to 0. Okay. So let us calculate the solubility product by constructing a cell like this. AG, I'm going to consider a cell like this. AG, AG plus BR, AG, BR and AG. Okay. So two half cells are there. If we write the reaction of anodic half cell, it will be like this. AG, AG plus, that is AG. Here AG is converting into AG plus. So oxidation reaction, 1 electron. If you write the cathodic reaction, it is reduction. Right. So AgBr, by abstracting 1 electron, converts to Ag plus Br minus. Here also Br minus. Okay. So the entire cell reaction is like this. Ag and Ag will be cancelled and the 1 electrons are also cancelled. So the entire reaction is AgBr reversibly gives Ag plus Br minus. Okay, let's calculate the solubility product by considering this reaction. AgBr reversibly gives Ag plus Br minus. According to Nernst equation, E equal to E0 cell minus RT by NF. Here Ln concentration of Ag plus into concentration of Br minus divided by AgBr. Ag, since AgBr is a solid substance, the concentration term equal to 1. And we already told that for an equilibrium reaction, E value equal to 0. Right. So this is equal to E0 equal to E0 cell minus RT by NF Ln Ag plus into Br minus. Actually, if we consider the saturated solution of silver bromide, the reaction is also like this. AgBr reversibly gives Ag plus Br minus. So this term can be considered as the solubility product of silver bromide. Right. So this is KSP. Okay. So if I rewrite this equation, I'll get RT by NF Ln KSP equal to E0 cell. Here we are going to calculate the solubility product. So I'm going to bring all other terms into right side. Before that, I'm going to convert this natural logarithm to the base 10. So I'll get 2.303 RT by NF log KSP equal to E0 cell. 2.303 RT by F equal to 0.059 divided by N log KSP equal to E0 cell. So log KSP equal to E0 cell divided by 0.059 into N. So from this equation we can calculate solubility product KSP. By taking the anti-log of this value, we can calculate the solubility product of any reaction, right? This is E0 value, E0 cell value, and we know E0 cell equal to E cathode, E0 value of R minus E0 value of L, or E0 cell equal to E0 value, electrode EMF value of the cathode minus EMF value of anode. Now, if we talk about hydrolysis, we can calculate the degree of hydrolysis and hydrolysis constant by using EMF value. Okay, let us take an example. Now I am going to hydrolyze ammonium chloride. So if we hydrolyze ammonium chloride, we'll get ammonium hydroxide NH4OH and HCl. Or we can write it as H plus ions and Cl minus ions. So simply we can write it as NH4 plus on hydrolysis, we'll get NH4OH plus H plus. Right. Since this is an equilibrium reaction, we can calculate the equilibrium constant K. K equal to concentration of products NH4OH into H plus divided by concentration of NH4 plus into water. Concentration of water. Here we can bring concentration of water into LHS side. Since here we are going to calculate the equilibrium constant of hydrolysis. So here LHS side becomes K into concentration of water. Right. This can be written like this, KH, that is equilibrium constant for hydrolysis. So hydrolysis, equilibrium constant for hydrolysis or a hydrolysis constant KH equal to concentration of ammonium hydroxide into concentration of H plus divided by concentration of NH4 plus. So if we know the concentration terms, we can easily calculate the hydrolysis constant. So let's take an example. So just imagine that we are dissolving ammonium chloride in V liters of water. V liter of water. Initially the ammonium chloride, concentration of ammonium chloride is maximum, that is we can take it as 1. Then the concentration of NH4OH and the H plus are 0. That is, it is hydrolysis process is not started. So when hydrolysis process occurs, just imagine alpha volume of NH4OH and H plus ions are formed, then this convert to 1 minus alpha. Since V volume of water is used for hydrolysis, we can take it as 1 minus alpha divided by V. Here alpha by V, here also alpha by V. So this will be equal to, K will be equal to, KH equal to, concentration of NH4OH is alpha by V. Here H plus also alpha by V divided by 1 minus alpha divided by V. This V and V term will be cancelled. So we'll get alpha square divided by V into 1 minus alpha. This is the hydrolysis constant. Okay. Hydrolysis constant KH equal to alpha square divided by V into 1 minus alpha. Here alpha is the degree of dissociation. If we want to calculate hydrolysis constant, we should know the value of alpha. Right. And the degree of dissociation value can be calculated by constructing a cell by using the aqueous solution of same salt as an electrolyte. So let's go to the details of the calculation of degree of dissociation by using cell reaction. So here I am going to construct a cell like this, platinum, H2 gas, and a salt solution. Since I'm going to find out the hydrolysis of ammonium chloride, the salt solution preparing here is the same salt. Okay, that is ammonium chloride solution is taken as the salt solution since I'm going to find out the hydrolysis of ammonium chloride. And I require a standard electrode. I'm going to take standard calomel electrode. Okay, here the cell depends, the EMF value of this cell will entirely depends the concentration of H plus ions provided by the hydrolysis of ammonium chloride. Here E value will be equal to E standard calomel electrode minus 0.0591. Since I'm going to take the logarithm base to 10, so log H plus. From the previous, the concentration of H plus is alpha. Here we are taking V volume of water to prepare the aqueous solution of ammonium chloride. So concentration of H plus is alpha divided by V. So E equal to E standard calomel electrode minus 0.0591 log alpha divided by V. We know the value of standard calomel electrode is 0.242 or 24. Precisely it is 2415 volt minus 0.0591 log alpha divided by V. So from this equation we can calculate the degree of dissociation alpha, and if we know the alpha value then we can easily calculate the hydrolysis constant KH, because KH equal to alpha square divided by V into 1 minus alpha. So from EMF value calculation we can find out the value of degree of dissociation as well as hydrolysis constant. Okay.